For the last multiple videos, we've been learning about quadratic equations. We've been learning how to, first of all, factorize just a quadratic expression, and then how that helps us to solve quadratic equations, and then to derive, first of all, and use the quadratic formula. Today we'll be looking at what they look like if we plot them out onto a graph. And we'll be learning any equation. So this is the general form of an equation. Ax squared plus bx plus c. Remember, a, b and c are just numbers, we don't know yet. So every equation looks like this. And we'll be learning what happens when we change the sign of a. A is a positive, a is a negative. We'll be looking at what happens when b squared minus 4ac, this is this b, a and c here, when that's bigger than 0 or equal to 0 or less than 0. Now remember, that's from the quadratic formula. Usually you'd see it inside a square root, and that's important. And then we'll quickly discuss, although I can't show it on the board as easily, what happens when I change c. When I change the number c, what happens? And then finally I'll talk about roots and factors of a quadratic. Because everything here before is something we can learn about the picture of a quadratic by just the numbers. Whereas this final one, it'll be more what a picture can tell me about the numbers. What can the picture of a quadratic tell me about what the equation will look like, and how I can actually get the numbers just from a picture. Right, first of all, I should mention how I'm plotting them. You'll be used to saying x, y, the xy axis, or sometimes we might say x and fx. I'll go with the y, the use of the y now. It looks a little better in a graph form. I'll just change this to y as well. But I want most people to know it's really the same thing. It can be interchanged quite easily. It's a function in x, and often we use y as the placeholder for the answer. In fact, we will be making y equal to 0 we made y equal to 0 in a lot of the equations we solved. That's how we like this to equal 0 to use our quadratic formula. And we'll see partially why that is. Well, one way or another we will. Okay, first of all, when a is bigger than 0, we get a graph that looks like, it could look like multiple ways, but it has this shape. It could be anywhere on this, depending what b and c are, but it has a positive shape. Often people say it's like a smile. Positive is happy, negative is unhappy, because a negative one looks like this. Now this is because the x squared is the most important number in a quadratic, and I say that because it's the biggest, or how its order becomes, it dominates the other ones. So how to describe that? Basically, if x was a really big number, for now we can just say something reasonable like 1,000. X squared becomes 1,000,000. 1,000,000's pretty big, and remember this number here is only going to be 1,000. So 1,000,000 is a lot bigger than 1,000. Now, in fairness, b could be big enough to deal with that. But what if x was 1,000,000,000, 1,000,000,000,000, 100,000,000, a Googleplex? It would quickly get out of control. So the x squared is actually the most important part of it. When we go far to the right or far to the left. And because it's a square, I know it's always positive. So that means I will always be up here and up here on the left and right. So I always get this shape. It might look like many different things. It might be wider depending on what number a is. But it will ultimately go up here and it will ultimately go up here. And the same for this. If a is a minus number, 1,000,000 multiplied by 1,000,000 is still minus when you multiply it by a minus number. You'll get the opposite. So you might have another shape that looks more wide, but you will ultimately have a shape that looks like this. A curling downwards. I don't have good language for that, I'm afraid. I'm sorry. But a negative shape like this. To be more precise, we won't learn differentiation or calculus for a good while, But this is always getting bigger as I move left to right. Even though it's going down less. Its rate of getting bigger is always positive. Is the exact way. I'm sorry, I'm not explaining that. For now, for this level, all we need to get is it's this shape. It's this shape. In differentiation and calculus, I'll talk more about that. Okay, moving on then. B squared minus 4ac. To remind you the minus b formula, we get minus b plus or minus square root of b squared minus 4ac over 2a. I'm going to rub this out again because I don't really want it up there. But that is where this is coming from, b squared minus 4a. And it's inside a square root, I'd like you to know up there. So this part inside the square root, b squared minus 4ac. When it's positive, that means we'll get a number out. The square root of a positive number is a number. We get an answer. And then, because of the plus or minus in front of it, we'd get two answers, in fact. When we get this, we get a shape actually similar to this. I'll write it as a negative one. Why not? The important thing to know here is we get two hits. We hit the y equals 0. We hit the y-axis twice. Sorry, the x-axis. Y equals 0, the x-axis. We hit it twice when it's bigger than 0. That's because, well, as I said, we'll get an actual number out for this. We'll get square root of this, which will be a real, which will exist. We'll get plus or minus it, plus or minus it. Doesn't have to be one side or the other. It could look just like this. Could look just like this. All of these pictures are b squared minus 4ac greater than 0. Okay, when it equals 0, what do we get? We might get something that looks like this. It hits the axis just once. So remember that equation again. Maybe I should have left it up there. Minus b plus or minus the square root of this. Well, if this is equal 0, plus or minus 0 doesn't change it. We only get one answer. One answer here. Now again, it could be underneath, it could be over this side. The important thing is we will only hit the x-axis once. And if it's less than 0, we'll get something that looks like this. It will not hit it at all. If we try and use the minus b formula to solve it, we will get the square root of a minus number, and we cannot solve that yet. We do not have, in fact, in this picture, we cannot solve it at all. We would need to introduce complex numbers, a whole new dimension really to look at to solve it. But the shape will look something like this. We will have no real roots, and we'll talk more about what the roots do in a minute. Now, changing c, that's an interesting one. I'll draw this picture again. But if I change the c, it could look like this. If I change it again, it could look like this. Sorry, that shape is meant to be identical. These are meant to be identical shapes. All it will change is its height. If I change c on this, it will just move up or down. If I change c, it will just move up or down. Also, it should be noted, c, this is not the best drawing for it. I'll leave that one there. C is this number here. C is this number here. C is this number here. It's not, doesn't hit it there. Well, it hits it somewhere up very high. C hits it somewhere up there. Because that is simply because x is 0 on this line, on this line, on this line. I'll use this one here. On this line, x is 0. That means that is 0. That is 0. And we're just left with c. So we often call c the y-intercept. We'll see that in coordinate geometry a lot more, where we draw lines a lot. But we'll still have a y-intercept. Okay, the final thing, and maybe the most important, is roots and factors. Because you'll often see this language being used. If I was given a picture, and if somebody was kind enough to give me numbers, let's say 1 here. Picture doesn't have to be that good. As you see, I didn't even use a ruler for most of it. Pictures, it's not important to get them accurate at this level. It's the understanding in them. It's the numbers in them. It's the concepts that's important. So in this question, let me point out all the roots I've drawn on the board. These are the roots of this equation. It's what happens when an equation is equal to 0. We get these 2 roots. This one has no roots. This has 2 roots. When I change C a little, it has no roots. This has 1 root. Sometimes we say it has 2 roots, but they are both equal to each other. 2 roots. 2 roots. 2 roots. So we can have 1, 2, or 0 roots. That is simply what the root of an equation is. It's when this equals 0, it's the answer. It's the answer to the question. When y equals 0, which is when x, all along the x-axis, the roots are simply the answer to the equation. So we've been finding the roots to many equations, but we've just never used the language before. And the factors are simply x minus the root. X minus the root. So x minus the root of minus 2. In this case, a factor is x minus the root. They are the 2 factors of an equation. So if you know this is a quadratic, and they have told you the roots are minus 2 and 1, we can quickly write the factors to be x plus 2 and x minus 1. In fact, we can go further and we can multiply this out. We get x squared plus 2x minus 1x is 1x minus 2. That is a quadratic. That is this quadratic. This is fx equals this. From the picture, we can get back to an equation. And that's it. That's all I wanted to say in this class. We will use these facts more. We will talk more about them when we do coordinate and geometry. Be aware, examiners do like to throw in these things, especially the words roots and factors. Be ready for that. And they like to put it into questions that you need to use this knowledge. They like to tell you something like, show me why the equation has no root. It would be because that number is less than 0. They like to tell you the equation only has 1 root, and maybe leave one of these letters missing. They tell you some numbers and leave one missing. You will now know that this is equal to 0. You can solve it. So this is quite important, but there's not much more I can say about it. Okay, thank you for watching and have a good day. Bye.